In this video, we'll look at two possible errors that can be made when doing hypothesis testing. Since hypothesis testing relies on probability to draw its conclusions, there's always the possibility that we make the wrong conclusion by pure chance alone. Let me tell you a little story to illustrate what I mean. A sort of fable, if you will. Once upon a time, there was a small peaceful village in the mountains. Things were mostly quiet. The villagers were mostly farmers. They tended to their livestock, and that was usually about it. But they knew to watch out for predators from the nearby forest to keep their livestock safe. One day, a mischievous boy decided to have a little fun at the villagers' expense. So he ran through the town yelling, "Wolf! There's a wolf in the village, and it's gonna eat the livestock!" Now, the villagers were not only farmers, but also statisticians. This is a fable, just go with it. The villagers decided to apply hypothesis testing as a framework to figure out what was going on. They started off by coming up with two hypotheses. The null hypothesis was that everything was normal and there was no wolf. The alternative hypothesis was that there was in fact a wolf wandering around the village. From here, there were two possible outcomes. They could fail to reject the null hypothesis, which means that they didn't have enough evidence that there was a wolf and they could relax. Or they could reject the null hypothesis, which would mean that they all come running with their pitchforks to scare the intruding wolf away. Now, there really was no wolf, but because of the boy's cries, the villagers grabbed their pitchforks and ran all around the village trying to find the wolf. When they finally found that there really was no wolf, they realized that they'd committed something called a type 1 error. The null hypothesis was true, but they rejected it anyway. Put another way, their result was a false positive. Their admittedly flimsy hearsay-based evidence told them that there was a wolf, when really there wasn't. The next day, that same boy was out wandering around in the fields. When he saw something, he squinted to get a better look, and to his horror, he realized, oh no, it was a wolf, and it was heading straight for the village. As quick as he could, he ran back to the village, shouting, "Wolf! There's a wolf in the village, and it's gonna eat the livestock!" Once again, the villagers went back to their hypothesis testing. But this time, they didn't believe the boy, because he'd already lied to them once before, and they didn't want to fall for it again. So they laughed at him and told him to go home. But a little while later, they heard a huge commotion from their livestock. So they went outside and found to their dismay that there really was a wolf after all. A number of them, in fact. After all, wolves do hunt in packs. And they'd already picked off a few of the sheep. The villagers realized that this time they'd committed a type 2 error. The null hypothesis was actually false, but they failed to reject it. Put another way, this had been a false negative. Their evidence led them to believe that there was no wolf, when really there was one. So the moral of the story, besides the obvious ones about spreading misinformation, is that type 1 and type 2 errors are what you get when you make the wrong conclusion about the null hypothesis. If the null hypothesis is true and you reject it, that's a type 1 error. But if the null hypothesis is false and you fail to reject it, that's a type 2 error. An important thing to note, though, is that even though we call these errors, they don't mean that you as a statistician did anything wrong. Remember that in the real world, hypothesis testing involves probability, because your data that you use to test your claim involves taking a random sample. Even if you do everything correctly by the book, your methods will still occasionally lead to the wrong conclusion by chance alone. The probability that you commit a type 1 error is actually equal to alpha, your significance level. So if you've set a 5% significance level, then you're willing to accept that 5% of the time you'll make a type 1 error. But if you try to just decrease that probability, you'll actually end up increasing the probability of a type 2 error, which statisticians call beta. As always, there's a trade-off. But statisticians still do their best to mitigate this chance, for example, by using a large enough sample size. Let's take a look at a slightly more realistic example. Testing the effectiveness of new drugs. When a pharmaceutical company wants to determine whether a new drug is effective, their null hypothesis is that the drug has no effect at all, while the alternative hypothesis, the one that they're hoping to find evidence for, is that the drug is actually effective. Based on these hypotheses, committing a type 1 error would mean that the drug has no effect, but we conclude that it actually is effective, and put it out on the market. On the other hand, committing a type 2 error would mean that the drug actually works, but our evidence ended up not being enough to show that it works, and as a result, it never gets released. Something you might want to consider here: which of these two errors do you think is more serious, and why? Oh, and one last note while we're talking about making the wrong conclusion. Wolves get a bad rap because of how they've been portrayed in all sorts of media. But they're not really a danger to humans. Rather, they're actually in danger themselves. So instead of grabbing a pitchfork, consider going to saveourwolves.org to learn more.